Hey everybody, time for day 7 in my packet, or the double replacement reactions, wherever that comes in. I think I numbered it wrong anyway, but be sure you read through the experimentation outline, procedures, and cautions that go along with this experiment. We're going to be running through these in a well plate today, to see if we can make observations about the reactions. All right, so we're going to try to organize it by well plates. I put a note card behind it to make it a little bit easier to see what's going on. For these reactions, we are using mostly solutions, so you're going to see a lot of interactions with solutions. First one being our copper 2 nitrate. Copper 2 nitrate is an actual nicely colored one, and that will be reacting with our sodium hydroxide. All right, so in well plate 1A, we're going to place 10 drops of the copper 2 nitrate. And then 10 drops of the sodium hydroxide. All right, hopefully you can see that we have provided some product out of this reaction. Looks to be blue and chunky. So make sure you take down those observations. Now we're going to switch out the copper 2 nitrate for another nicely colored solution, which is our iron 3 nitrate. Stains everything. Good idea to wear gloves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's a sneaky extra one there. That's okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Ooh, hate that sound. All right, so we do have a material that's been produced out of that reaction. You can see, hopefully, make observations about that. So that's reaction 2. Reaction 3 is similar, except with potassium nitrate. Potassium nitrate, you'll notice, doesn't have a color. We'll do this in cell A3. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And this reaction also is with sodium hydroxide. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That might have been 12. Oh, what? There's a little cruddy in there. Dang it. All right, so we got a clear solution and a clear solution mixed together. To me, it looks like a clear solution is produced out of that reaction. If there wasn't a reaction, if there was a reaction at all. So that was number 3. And we're going to do, in the next reaction, potassium nitrate and barium chloride. So we're going to keep our potassium nitrate, but we're going to switch it up and add a barium chloride to it. Barium chloride is a clear aqueous solution as well. So we'll see if we get anything out of this one. We're going to do it in this well plate here below the copper. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And barium chloride. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right. Reaction 4, right here. Not too much going on there. All right, let's try the barium chloride again, but this time with the potassium sulfate. Here's our potassium sulfate. We're going to react that with our barium chloride. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just trying to get about the same amount of solution in there each time. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Of course, measuring by drips is accurate if you can actually do it. There's our reaction 5. Maybe it's easier to see without the note card behind it because it did produce a white material, cloudy looking. We can see that definitely different than reaction 3 and 4. And in our last, 1, 2, 3, 4, 5, yeah. In our reaction 6, we're going to use lead nitrate. Now again, we've used the lead nitrate before in other labs. It's a heavy metal contaminant, so we're going to have to be careful about disposal of this. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We're going to add to that potassium chromate. Potassium chromate is a yellow liquid. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Boy, am I good at counting to 10 or what? All right, so it does have a yellow color, partly because of the potassium chromate, but what I also want you to notice is the chunkiness of it. Kind of hard to see the cloudy aspect of that, but there is a film of material that's depositing on there. So when you have solids that are produced, we call that a decomposition. We call that solubility. So it forms a precipitate. Precipitates are a solid that's being produced from 2 aqueous solutions reacting together, and that's pretty typical for double replacement reactions to do that. So be sure you did make observations in the lab and try to come up with predictions for what is happening in those reactions. Remember, if you think it's a no reaction, then write no reaction in the products, and we'll talk more about how these reactions work later on.